Again, my name is Alex Worsfold. I'm a certified SOLIDWORKS expert for the SOLIDWORKS products. I'm a senior application engineer with computer-aided technologies, and I've been doing this for the better part of 2 decades now. I've used SOLIDWORKS since 1998. I've seen a lot of enhancements over the years, and this one is one that's pretty cool. Hope that you guys get a lot of information out of this one. So for the agenda today, we're going to discuss meshes. And the first thing here is just importing. There's lots of different types of mesh file formats. Those can be imported as either solid bodies or surface bodies, as well as graphical bodies. We'll talk about some basic workflows that you can use when importing. We'll also talk about the different types of features that can be used. Generally speaking, though, anything that you're adding is usually just added directly to the body. But if you wanted to maybe combine things, they have to be compatible. So we'll talk about that. And then lastly, the very last feature here on the agenda is something called Scan to 3D. And for many years, this was the only way that we could import these types of meshes. So we'll review kind of the differences that we see and how to use this tool as well if you're unfamiliar with it. And as far as importing mesh formats, I think it's important to point out that the standard version of SOLIDWORKS can now import mesh files, so STLs, OBJs, and whatnot there. But Scan to 3D is actually a pro and premium feature. So those higher level packages for SOLIDWORKS are able to import different types of data and different ways to manipulate that data. But it's not just meshes, it's also point clouds. So we'll take a look at some of those examples as well today. Now, when you import, and we're actually taking a look at the system options here, if you go into just the import options, or if you're in the import window and go to options there, you'll see that there's just some simple options for STLs. So the two options, solid body or surface body, those are going to bring in standard BREP, which is just a body representation. It's what all solids and surfaces that are generated natively inside of SOLIDWORKS get created with. And then there's a third option there, which is graphics bodies. And you'll notice that there's another option down here for mesh bodies. So mesh bodies, if we turn this on, creates something called a mesh BREP. Now, the two are not technically compatible with one another. So BREP and graphics bodies can both be converted to mesh BREP bodies. So let's take a look at the differences between these formats and what we can do with the files themselves. So first of all, we're just going to open up an STL. So I've got this fender mesh part here, and we're going to try to import it here as a surface body, but I'm going to use this option here called Create Mesh Bodies bounded by faces. So when we import this, you'll notice that if I click on the mesh itself, it creates, or it selects, one complete face. And if we look over here in the tree, we see that there's a different representation for a feature. So that represents a mesh body. Now, if we open the same file, but without that mesh body option, so we're going to turn that off. This time when we import the file, we're going to see a little bit of a difference here. Now, number one, you'll notice that this takes quite a bit longer to import. And that's because it's actually translating each individual polygon to a separate face within the software. And once it's opened up here, you'll notice that in the tree, we get a standard looking BREP body representation in the feature tree. And if we kind of compare some other things here, you'll notice that, again, we can select each individual face. It creates a one flat face for each polygon. And you'll notice that it's not really smooth here, and that's because of the way that the polygons are laid out. They're all flat. But if we kind of look at the difference side by side between a regular mesh BREP, a regular BREP part and a mesh BREP, you'll notice that on the right it's much smoother. And that's because of the way that it's imported and translated into one face. So now if we go back to the regular BREP body here and we try to, sketch over the top of it, this is going to react just like a normal SOLIDWORKS part. So if I turn on edges and start a 3D sketch, notice that I can, reference edges, midpoints, everything that I'm normally able to reference within that part. But if we switch back to the mesh BREP part and try the same thing with a 3D sketch, again, we'll turn on the edges here, but you'll notice that they're kind of a lighter color. They're a little bit harder to see, but we can still reference those points or those vertexes on the mesh. What we can't reference, though, is things like midpoints. You'll notice that as I'm trying to find a midpoint there, there's no data there to select. There is, if you notice down here on the filters toolbar, there are some filters that we can use to select those types of things. But if we have those filters turned on, we'll notice that things like selecting relationships there, I can't select that relationship. So if I wanted to delete it to be able to move that, I have to go do that from the tree. And even with filters turned on, if I'm trying to line that up on top of another vertex, I can't drag and drop. I can add a relationship manually, like you saw there, but working with mesh BREPs and graphics bodies are a little bit different when it comes to this type of geometry. So finally, let's import a graphics body. Now this format is the quickest to open. And there's still lots of things that you can do with graphics bodies. You can reference for creating new planes, new axes, things like that. And there you can see the graphics body icon in the tree there. But you really can't modify that geometry. And we're going to talk a little bit more about converting that here in a second. So if I select that icon up there in the tree, it can be converted to a mesh body. You can also change the density of the mesh. We'll talk about that a little bit later. Again, that group facets into faces. So once I complete that, now the graphics body has been converted into a mesh body that we could then maybe modify, cut holes through, do all sorts of things with it. So let's switch gears here. We're going to go back to the agenda and take a look at what we're going to look at next, which is just what we can do with the actual mesh bodies, what kinds of features we can use, and how we can make changes to those. So the workflow, of course, when you import, you can either go right from an STL to either a graphics, a mesh body, or to a regular BREP body, and then that BREP body could be converted to a mesh file if needed. But they do need to be compatible bodies. So if you have, maybe another solid body or another surface that you've created in SOLIDWORKS with regular features, that body would have to be converted to a mesh body if you're working with STLs or other types of mesh formats. So compatible bodies, they must be converted to to be able to use things like Boolean operations, like maybe combine or subtract. And of course, the graphics mesh, it's a little bit limited in what you can do with it without converting it, but you can move it around. You can create references to it, and you can actually create sketches and create references from that as well. So here's another example where maybe we want to put some fillets on there. So using standard tools, I can just select some edges and apply that fillet. And again, notice in the tree over there on the left that the body is a mesh body. So it's already been converted from a graphics body. If I wanted to convert these fillets over into chamfers, I can just right-click on that and edit and switch this to a chamfer just like any other feature inside of SOLIDWORKS. So just because it's a mesh body doesn't mean it behaves much differently. Other things like surface offset. So if I pick a face here and I wanted to offset that and create a new body, I could then maybe extend that body so that we can use a trim later on. So make sure that it's extending past the boundaries of the other surface there. And then I can use a surface trim and tell it what areas I want to remove. So the overlapping geometry, there we go. So now we've removed 0.5 millimeter from that face. Other things like check. So check is useful for finding where there might be an open boundary here. So this part that was imported didn't actually turn into solid because it's missing a face here. So it's showing me what area is open. I can even use a tool like delete hole. So if I want to remove that area, SOLIDWORKS patches in the geometry around the hole. Speaking of deleting geometry, I can also use delete face to delete other areas on the model. So for example, these two features here, we don't want those anymore. I can delete them and let SOLIDWORKS patch that back in. So taking a look at a little bit different example, in this one, we might want to reduce the number of elements that were originally imported. So I can use a percentage here, and then SOLIDWORKS will calculate the elements that need to get removed. Of course, this can take some time, so we're going to kind of skip ahead on that. But here you can see the difference in the detail that has been removed. Now we could also use this graphics body here to create other geometry from. So using the tangent select facets tool here, I can select all of the facets based on a given angle tolerance. So I just easily select those elements there, and SOLIDWORKS is able to generate an axis based on the average of the position of those elements. So that's pretty neat. Once I've got that axis in there, I could use that to create a new plane. So here I've added a new plane and just looking at the definition of this. So I'm using the front plane here to just make it parallel to that axis at a certain position there, or perpendicular to that plane around the axis. And then on that plane, we could maybe use a sketch to find the intersection of the mesh on that plane. So using this sketch here, so I used the intersect tool. Notice we're on the mesh modeling tab, but that intersect tool is also found in sketch tools as well. And then from there, we could use that sketch to help create some new lines and geometry for a revolve. So here you can see in this sketch that I'm just referencing the original intersection sketch that we referenced from the mesh. So now we're using, analytical geometry like lines to create a revolve. So now I've got more of a simple shape instead of a bunch of elements. And then I could use the same techniques to create the teeth for, that go around the gear. and then pattern that. And then finally, a chamfer down here at the end. And then I've also got a feature here that's actually converting the original graphics body into a mesh body. And that's because I actually want to maybe do a comparison to this. So the mesh body here, once we created the other geometry, maybe we want to compare what's been added and what's been removed. So if I select the original mesh there and the new body that I just created, this is going to give me a little bit of an analysis here that'll indicate, how much areas need to be maybe still worked on, maybe another cut needs to be added. So those blue areas, there's a little notch in that surface, and then the red areas show me where geometry is missing from the original mesh. So maybe I've got some more work to do in order to add those. But we can also look at this in the other direction too. So if we turn off that analysis and look at this in the other direction, if I select the new body that I created, followed by the mesh body, the analysis is going to show on the mesh body instead of the other solid body that I've created. So I can look at the analysis from both directions if needed. All right, so now that we've seen how to import and work with meshes, let's take a look at a feature that creates meshes from pictures. It's called the 3D texture. So 3D texture converts black and white images into a mesh or polygons. Another term for this is called a height map, where the different colors, the white and black are just binary, to where anything that's black is low and anything that's white is higher up as a height map. So that 3D texture can be used to create a graphics mesh that can then in turn be used to create a BREP mesh. So if we needed to make some modifications or make some cuts through it, we still have that capability. And the graphics mesh can also be saved directly to STL if you wanted to create a 3D print. So in this example here, we've got a simple looking cylinder, but the thing to keep in mind is the texture is not limited to these types of shapes. You could actually use any kind of curved shape, but all I'm doing is I'm applying an appearance to that face. In this case, just the standard checkerboard pattern. Checkerboard might be cool, but I want something that's a little different than this. So if I go and edit my texture, so I'll just edit the appearance here, and I'm going to browse for a different image. There are some 3D textures that come along with SOLIDWORKS here. So this path that you see, we can use one of the examples found in that folder. And of course, just like any other appearance, I can change the size of the texture or the image. And all I'm really trying to do here is line up the hexagons on the edge there where that seam comes together. Never mind the little bit of a graphics glitch that you see there. That's just a product of my setup. But once we've got that texture applied, you'll notice up here on the features toolbar, we've got 3D texture. So we just need to select which body we want to texturize, which appearance we want to use, and then we can start to refine the size of the elements. So I'm going to go ahead and crank up the maximum element size, make those a lot smaller, and then I'm going to adjust my height that I want to emulate. So right away you can see what's going on. Now notice there is a texture refinement slider there. I have it set at 0%. And the reason for that is that slider is pretty time intensive. It takes a little bit of processing power, and really all it does is it any areas where you've got more of a difference in change in the height, it will refine those elements in those areas. I wasn't really concerned about that with this model, so I went ahead and left that part out. And then, like I said, this creates a graphics body that can even be saved out to STL. So if we create an STL and then open that up so you guys can take a look at it, I'm just using the Windows model viewer here. And this is the resulting file that gets created from that. So 3D texture is a great way to, add some kind of, detail to the model that would be, otherwise difficult to create with standard SOLIDWORKS tools. And then lastly, let's look at how meshes can be imported using Scan to 3D. So we're going to go import a part here. So I've got a 3D mesh here. This is actually a VRML model. And you'll notice in the tree that the mesh is a little bit different. It's got a little bit different type of icon when you import with this method. And again, remember this is part of SOLIDWORKS Pro and Premium. So if you have standard, you won't be able to import meshes this way. But from here, I can right-click on the mesh, and there's several options here that I can choose from. There is an option there that you can use to decimate or adjust the number of mesh elements that were imported. In this case, you can see there's 28,000 faces. This came in as a pretty clean mesh, so I didn't really need to change that. But if I wanted to adjust that, I can, and that's under the mesh prep wizard. But on the surface mesh or the surface wizard here, if I had multiple meshes, I'd have the chance to pick a different one here. We only have one, so I'm going to continue. Now there's two different options here. We're going to start off with the guided creation one, but the automatic creation, I will show an example here in a little bit. And it's just that, it's pretty automatic. The guided creation, what it does is it allows us to create individual faces from the mesh file. So we can also optionally split the mesh. So if it was symmetrical, this part is actually symmetrical, but I didn't have a plane in the middle of the part to split it. So we're going to go ahead and skip this part. And then from here, what it's doing is it's breaking down the mesh into different individual faces. And this can take some time, so I've skipped past some of that lag in time there. Now, at this point, I could hit apply, but there's a sensitivity slider here that I can use for it to automatically paint the surfaces. And if we kind of spin the model around here, you can see that each face is a different color. Each color is going to generate a new face for the model. But you can see that there's some faces that are this red color around that green face at the top that SOLIDWORKS kind of thinks that it's noise. Well, I actually want to capture that data. So once I hit apply here, it's going to apply the colors, but we want to actually go through here and make some touch-ups here. So for example, I can select the existing green color and just add these other elements to that, just indicating that it's, that we want that to be part of a face. I'm not going to worry too much about accidentally selecting other colors here because we can make that change later on. But if I want a different face, I just select a new color and then select the elements that are going to be part of that new face. And again, making mistakes here is just part of the game because you're painting with the cursor. But again, if you make a mistake, you can just select the existing color for the face that's adjacent to it and select over the top of it. Now, of course, this is rinse and repeat. I'm just going to speed the video up here so that we don't waste too much time. But essentially, I'm creating another color for each individual surface that I want SOLIDWORKS to identify. Once I'm ready, I just extract those colors. SOLIDWORKS creates individual faces from those colors. This does give you the chance to go back and make changes to this. So I will show an example in a bit here on how we can modify that. But for now, we're just going to go ahead and go to the next step. We'll go ahead and accept this. And what SOLIDWORKS does is it generates a new face from each one of those colors that are basically touching the original mesh. From here, we could continue our work if I wanted to trim these up. So I'm going to use a mutual trim here and just select and keep these faces here. And we forgot one at the bottom. There we go. So got rid of some of the excess there. And we can continue on with another trim. So for example, here, those smaller surfaces don't quite extend past the model. So I'm going to use an extend. And again, still didn't quite go past the edge. So we'll just make a slight modification here and extend that just a little bit further. So there we go. We'll be able to trim that off. And again, it's just rinse and repeat for the rest of these surfaces here. So we're going to kind of skip ahead to the next section. Once I've got those all extended, again, I can use a trim. So we're going to use a mutual trim and keep the main body here, the top surface, and then the little individual faces around that boundary. I really like the trim tool here. It allows me to select through because it hides what I've already selected. So it makes it super easy to select all those inside faces. So there we go. We're not quite finished yet, but we do have one complete surface body. From here, that could be enclosed into a solid. So we're going to create a solid volume using the thicken feature. So now it's a solid body. So what could we do from here? Well, if you notice in the tree, we've got mesh one and surface extracted one. So all those extracted faces get placed into an individual folder there in the tree. And then the individual broken out mesh files, those get separated as well. But we can go in and see each one of those meshes, and we can make a comparison back to the solid that we just created. So if I right click on the mesh, there's an option here for deviation analysis. So just like we saw in the other mesh types, with the scan to 3D option, we can also create these types of analysis. So we can see, exactly how much it maybe deviates from the surface that I just created and from the original mesh. And if I decide that this deviation is too much, then I can go back and make a change. So with that submesh that got created, I can go right back into the same surface wizard, go back through the same guided creation tool, and then extract the face. But this time, we're going to use this B-spline tool, select that face, and now we can start to make some modifications to it. So right away, you can see there's max and average deviations. As I change the tolerance, those change a little bit. Now, it does look like there's a pretty large deviation, but you'll notice that the surface actually extends from the sides there. But we can control the number of segments in the U and V direction, and then rebuild that as a new surface. We can also display a deviation analysis here. So if I want to see how closely it matches to that surface, we can see that it's a much tighter fit. Of course, there is some red areas at the edge, but that's because it's right along that chamfer. So from here, we could go ahead and accept this. And you'll notice once it's done, it creates a new folder at the bottom of the tree. Now I could go back and fix that, but I'm just going to use surface replace. So the surface that we had originally trimmed out, we're just going to go ahead and replace that here with that new boundary surface. And so now that's been completely replaced there in the tree, saving all the history that I had done earlier. Okay, so let's take a look at one last example. This time with this mesh, we're going to go and use the automatic creation method. So for this one, since it's so organic, it would just be better suited to select each individual or to let SOLIDWORKS create each individual face for the model here. And all we've got here is this little slider here for detail. We update the preview. And again, this takes some time to generate, so I have sped up this part of the video here. And what it does is it creates a patchwork of surfaces over the mesh body. And of course, because it's automatic, there is a chance that you might get some errors or some overlapping geometry. So you see that there are a couple of errors here. So once I click next, SOLIDWORKS will let me know that, hey, any surfaces that have errors, these are going to be removed. So we'll go ahead and accept that. And then when it's finished, it ends up creating a new surface body, a new regular BREP body over the top of that, that mesh data. Now, this particular file was brought in from an OBJ. And knowing what we know now about meshes, what would happen if we import this part using just regular SOLIDWORKS tools instead of scan to 3D? Let's take a look at that example as well. So again, we'll go ahead and use the regular mesh file option here instead of scan to 3D. And it also supports OBJ. I'm going to try to import this as a solid body just to see what happens. Again, this is going to create a normal BREP body just like we saw with scan to 3D. But again, because of the complexity, you'll notice that it did come in with errors. And if we look at the shaded without edges, we can see that it is faceted just like the original OBJ or object file. Well, what would happen if we import this as a graphics body instead? So because of the way that the graphics body works and the way that it's converted to mesh later on, we're going to get a much different result. So importing this, you'll notice it was super fast, but the mesh body is much smoother because of the way that it averages the surfaces over that mesh. So, just keep these kinds of things in mind the next time you need to work with a mesh file. And that is all I've got for you guys today.